Let's go over how you can add math to your document, the different types of math available, and also how we can add checkable math to our documents. So for example, let's define some function and then try to solve for its derivative. So we can write let, and now for f of x, we can go to the top toolbar and choose math. Here we have three types of math: inline, numbered, and multiline. Now we want f of x to be written in line with our text, so we choose inline, and we write f of x. We can use the arrow keys to exit the math. B, a function defined as, and now we can press enter to create a new line. And let's define this function in a centered math. So again, from the math menu, this time we choose numbered, and then we can write f of x equals, and let's say sine x, for example. Now notice that this math is numbered. If we want to get rid of that number, we can move over to the gear icon on the left and uncheck the numbered box. Again, we can exit the math using the arrow keys. So now let's take this derivative. Now we can write the derivative of f of x, but this time, rather than choosing the inline math from the top menu, we can use the shortcut Command M or Control M, which creates the inline math environment for us. Again, using the arrow keys, we can exit and write is. Now we can create a new line, and this time let's do a CheckMath environment so it checks our derivative. So from the top menu, we choose check and CheckMath evaluate. Now, on the left side, we want the derivative of sine x. So from the top menu, under basic, we choose d by dx. Then we can continue writing sine x equals cosine x. Then we can wait for CheckMath to evaluate, and it comes back that the expression is correct, as expected. Now let's discuss how we can edit math. So first, to enter math, you can either use the left or right arrow keys as shown, or you can simply click into the expression. Now, if you want to leave a math, then you can click out into some regular text, or you can use the arrow keys to get out, and lastly, you could also use escape. Now, it's very important that you don't write regular text inside a math environment. So let's enter this math environment again, and notice that there's a blue shaded background around our math. The menu at the top of the window has changed, and there are also three icons on the left of the math. So let's edit this function definition. Let's say that we want f of x to be defined as the square root of sine x over cos cubed of x. So we've already got sine x. Now let's add a fraction, and we can do this from the menu at the top of the window. So we can select our sine x, and under basic, we can select fraction, and this will create a fraction with sine x at the top. Now let's add the cos cubed at the bottom in the denominator, and we can do this by simply typing cosine cubed of x. Now there's one more way we can add to the math. We can use the backslash to bring up a menu. So if we select everything that we want inside the square root and we hit backslash, we can now search. So we know square root is SQRT, and we can see it at the bottom. Selecting that will add the square root to our equation. Let's go over user preferences. Notice in the math, we see that the functions sine and cosine are a different color than the rest of the math, as well as the background for the math environment. Now these color settings can be changed in the user preferences window, which can be opened by pressing Command or Control, comma, or open through the settings menu at the top of the screen. There are many preferences you can choose in this menu. I'll just go over a few of the important ones. First off, we have auto convert. Now this will convert your typing in a math environment to functions if you choose so. So rather than selecting sine from the math menu at the top of the window, you can simply type sine, and if you have auto convert set to functions or all, this will change the sine into a sine function. Now, by choosing functions, this conversion will only work with functions such as sine, cosine. But if you choose all, this will also work for fractions. For example, if you type frac, it will convert that into a fraction. Next, we'll talk about the CheckMath delay. So this is just the delay between when CheckMath checks over your expression and when you stop typing. So we recommend when you're starting out with using Hypatia to have this delay set to 5 or 10 seconds. This way, the CheckMath won't keep updating its evaluation as you type. Now, as I mentioned earlier, you could also change your math color settings with this menu. So here you can change the color of selections, math, and the background. So let's, for instance, change our background color from this kind of light blue. We can go ahead and use the menu to change it to more of a yellow shade. And now if we exit the menu, we can see that our math background has been changed to reflect our changes in the user preferences. Let's go over some basic CheckMath behavior. For now, CheckMath can check basic algebraic operations, limits, derivatives, and integrals. As you type, CheckMath will give you 4 different types of results. The first result is that your expression is correct, which is indicated by a green check mark. Next, your expression could be conditionally correct, indicated by a blue check mark. In this case, A and B both have to be greater than 0 for this to be true. Another result is a syntax error. Here we see that the sine function has no argument, and so CheckMath warns you with a yellow exclamation mark. Lastly is the incorrect result. This is shown by the red exclamation mark. Let's try an example. Here we can evaluate the derivative of x squared sine x. We can insert a CheckMath evaluate environment, and now I'll be writing this using the auto convert. So I'll only be writing the keywords. As you can see here, diff, and if we add a space, that translates it to the derivative, and we want the derivative of x squared sine x. So now we can do this by taking the derivative of x squared first, and multiplying that by sine x, and then we can add the derivative of sine x multiplied by x squared. So far, CheckMath says that our evaluation is correct, so that we can continue by pressing enter to start a new line. The expression on the left, we still want to keep the same, so we can leave that side blank, and we can continue working on the right side. So we can evaluate the first derivative to be 2x sine x, and move on to the second one, which evaluates to x squared cos x. If we wait for CheckMath to evaluate this, we see that we are correct. Okay, let's work on another example. Now here, we want to sketch a graph of the function x squared using GeoGebra. So we can go to the GeoGebra graphing website, and now we can use their freehand drawing. So we can go through their tools and scroll down, select more, keep scrolling down, and then we can select freehand shape. Now before we start drawing, let's change the axes. So under settings, we can choose settings and change the x min and x max to say -3.5 and +3.5. Now we can close the settings and we can start plotting. And we can draw a nice parabolic shape like this. So now let's take a screenshot of our plot. And once we take the screenshot, we can copy it and go back to Hypatia. Now once we're back, we can paste the image. And notice it's pretty big. So we have the inspector open, and under the inspector we can modify the width and scale the image down so that the width is maybe 300 pixels, and press enter. And we see that the image is scaled down, but now let's also center this image. So under alignment, we can choose center, and there we have it. a nice plot of the function. Let's work on another example. Here we're asked to evaluate the limit as x approaches 0 of sine x over x. So we can start by noticing that in the numerator, the limit as x approaches 0 of sine x is 0. And so we can write that down in inline math. And also, we see that in the denominator, the limit as x approaches 0 of x is 0. And so this limit is an indeterminate limit. Thus, we can use L'Hopital's rule. So let's add a CheckMath evaluate environment, and we can write out our problem. So the limit as x approaches 0 of sine x over x, then using L'Hopital's rule, equals the limit as x approaches 0 of the derivative of sine x over the derivative of x. So let's continue on a new line, press enter. The left side of the equation is still the same. And now we can evaluate these derivatives. So let's say that the derivative of sine x is negative cos x, and the derivative of x is 1. Now notice that the CheckMath will say that this is wrong, which in fact it is. The derivative of sine x is cos x, not negative cos x. So we can correct that, and we can let CheckMath evaluate the expression again, and we'll see that we are correct. So let's now evaluate this limit by simply substituting x equals 0 into cos x, and we'll find that the limit is equal to 1 over 1, which is equal to 1. And we can wait for CheckMath to evaluate this, and we see that this is correct.